And again, I have some slides posted, some code that's sort of a little more polished version of what we're trying to code up in class today. Some pure reading. This book here again is just read it. It's background information. This book has those little exercises you're supposed to do for participation points. And I'm releasing our first assignment today where you're writing some code in Eclipse and you're going to turn it in. So lots of little things going on. Try to stay on top of all these activities you're supposed to be doing in class. And certainly, since you haven't had any programming yet, really, you haven't had a big burden, you should certainly be up at this point with all your reading and exercises. Questions about any of those kinds of elements? Good? All right. Go to PowerPoint for a minute here. A program, it looks at it and says, int a equals 2. It tries to figure out what that text 2 is, and it says, oh, that's a number, an integer, and it stores that inside its memory in its own, not as a text, but as an actual number. And of course, that number is then lost until you type it again somewhere in the program, right? It doesn't have some name to it. Whereas a variable, which has a variable name, you can reuse over and over again. Num, you can use print num equals num plus 1, all sorts of stuff, right? So you can keep reusing those variables.
I don't know. I have no idea why it won't.
Hold on.
There it is. Okay. Some.
More importantly than literal in some ways, that you have a variable, again, which is a named location to store data. It needs to be declared with a type, so once it's declared, it stays that type. So for example, we have int age. In that case, age is always an integer, a number without a fractional part. And you can do things with variables. You can put new values into them, and you can evaluate what values stored inside the variable. Integers hold integer values, -1, 1, 100 million. Notice Java allows you, instead of writing numbers like what you do in the US, right? We put a comma every 3 spaces. Commas have other meaning in the program, so instead they let you write them like this just to kind of help block out big numbers. It's just a convenience thing. So mentally replace those underscores with commas or get rid of them completely, and it means the same thing. Doubles hold numbers with fractional parts. We can also write them like, oops, like this. This means some sort of exponent and really means the same as 1.2 times 10 to the 4th, right? So this is the way Java does scientific notation. We can hold characters, so characters are always a single letter, A, and characters have single quotes around them. You may see unusual looking ones like this thing here. That's Unicode. Unicode is a different way of representing characters that can handle more kinds of script. So if you want Arabic or Chinese or Japanese or something like that, you use Unicode, and it knows about all those different kinds of alphabets besides the Roman alphabet that we use, right? So it's a big world out there, and there's thousands of characters, and that's how you can access some of those things. Unicode also has your emojis and little drawing blocks and things like that. So it's reason to use it for you. Then there's bool, which holds true or false values. And we'll see the point of that more explicitly as we get into more complicated programming. We have expressions. Expressions evaluate to some value. So math expressions, things we're sort of used to. Anything that turns into a value is basically an expression. What part of that above there is an expression? So out of that little statement, which assigns something to tip, what is an expression here? What do you think is an expression?
Bill times 0.20.
So bill times 0.2 is expression for sure. And that's because, assuming there's some number stored in bill, you can do the math and that turns into some other number, like 5 or 16.8 or something. Any other expressions there? There are expressions there. So someone said Bill. Bill is an expression. It holds a number, right? It evaluates to something. So that's an expression. Actually, that can be considered an expression, a very simple expression. It doesn't have any operations involved with it, right? But it still turns into a value of some kind, 0.2. And actually, this whole assignment statement itself evaluates to some sort of expression. We'll see how to use that at other times. So expressions can hide in different ways in Java, but anything that turns into a value of some kind is an expression. And different from an expression is a statement. So a statement is basically a complete command in Java. And so declaring and initializing a variable is a statement. Adding a number to a variable and storing it back in that variable is a number, is a statement. And calling this print function here, this print method, giving some values is also a statement. And so we'll be learning different statements as we go into more programming concepts. One thing that we talked a little bit about is a string. So a string are like the other kinds of types. It holds certain kinds of data. In this case, it holds a sequence of characters. And you show a string with double quotes around that sequence of characters. So my name, David, is a string. And I can assign it to a variable of string type, capital string type. So like int is a type, and double is a type, string is also a type. So this says this variable name is going to hold a sequence of characters, and I'm initializing it with this literal string David here. So if you later evaluated what was in name, it would say string David is there. Very good to get that. I can also do things with strings. So it knows about some operations. So if I have a literal David plus a literal empty space plus Johnson, what does it think it means? Johnson. So it's an operation on strings. It just slaps them together, concatenates them together. And in fact, it's smart enough to know how to combine strings with other things like numbers. So in this second example here, full name. Okay, so I'm going to start a new program here. I have a project. I made a file, new Java project. And I called it CS1410 in class code. And inside here, it's split into has a source folder. Source is the actual text file that has the code in it. You'll also see if you look at on the file system where this is, you'll see a class folder or a bin folder, and that holds the actual compiled Java. So I'm going to go to source, and I'm going to add in a new package. We haven't really talked about packages. Packages are collections of code sort of under some similar theme, so we'll talk more about that. But for now, I'm just going to call this one the Lecture 3 package. Typically, a package starts with a lowercase letter. And in that package, I'm going to make a new class. And a class, again, is like can be a basic program or something that you run. And I'm going to say, let's make a main for me. This says public static void main. Do you want that to be created for you? And I say yes, because I forget like all the weird string arg stuff that goes in there. And so I'm going to just say, yes, give that to me for free. And I'm going to call this a tip calculator class. All right, so it made a package. It said it's a tip calculator class and has a main method. And again, the main method is where code starts. And this is a comment I'm going to get rid of for now. Let's do that little example with a string. Robot name. David. All that stuff. Plus 1,000 or 1,000. And if I do a system out print line on robot name, we'll see what's stored in there. So I'm going to run this. Came out with David 1,000. So, but it's all string, really. It's not really printing out something that's half string, half number. It can only hold one thing, right? It says, I want robot name to be a string, which means it holds a sequence of characters. And so it really is totally a string.
Just write a line with robot name. Does it have any kind of output?
So if I wrote robot name, no, it would evaluate to the string, but it's not an action, so it wouldn't show anything. There are languages like Python that you sort of bounce stuff back to the console by just typing the name of the variable, but it's not happening here. Your question?
If you had 1,000 stored in an integer variable, if you called it there, would it do the same thing, or does it need to be literal to make that assumption?
It should work. So int robot version. Okay. So here we're assigning 1,000 to this integer. We're adding that integer, concatenating that integer with David. It says that doesn't really work. We have to hold one thing here. It tries to what's called cast this into a string representation so it can combine the two appropriately. It succeeds in that, and we get one string out.
How in memory is a string laid out? Is it like an ordinary Java class, or is it like a string of, or is it like an array of characters? Or?
So we will say, so string is not like the other primitives, integer and double. It is what's called an object of some kind. We'll get into that. Internally in memory, though, each character just takes up a spot in memory, basically, and then there's some other stuff to kind of keep it organized. We'll just leave it at that for now. Okay, so let's go back to our tip program. And we had a double bill total. Total equals nice thinner out. And we had an int tip percentage equals 18, 20%, right? 20%. And then we had our double tip amount equals the bill total times the tip percentage. So if we run this program so far, it's going to declare a variable bill total and initialize it. So somewhere in memory, there's this named label for bill total and storing 100 in it. We're declaring and initializing tip percentage. It holds a value of 20. And then we're using both of those variables in an expression. And again, the way the interpreter does this, it says, okay, here's a variable. What's stored in here at this point? And it says 100. Here's a variable. What's stored in this point? It says 20. And it multiplies those together. Actually, so that gives me the big number, and I got to divide by 100 here to make the math work out. And then I could do my system out print line. The tip is tip amount. And I'm going to add a nice little period at the end to make it all be pleasant. Okay, so here I'm taking advantage of this concatenation thing to make my output be a little nicer rather than just spitting out a number 12 or something like that. Just going to say the tip amount is this amount so the user knows what's happening. And if I run this, I get that. Okay? So questions about this little chunk of code before I start changing this. We basically did that last class. And again, important concepts here are declaring and initializing variables, a little bit of expressions and how variables work in expressions, and then outputting things that include variables and literals, right? So we have a literal here, we have a variable here, we have a literal here. Now, I sort of briefly mentioned the problem with this program is if you want to do it for another bill, you have to go in and change the program in it. And so in a perfect world where everyone was a great Java programmer, that would be a fine activity. But you're not going to sell an app on the App Store. Here's some Java code, change it to do what you want it to do, and then hope people will figure it out after a big meal. So instead, we want to have this program interact with our user and ask them what their bill was and how much tip they want to give. So there's different ways to get input into a program. I'm going to sort of hack one way. I'm not going to really be doing it right in a way, but just to kind of show you some of the stuff we can do. Yeah.
Does Java evaluate using order of operations, or does it just go in order from left to right?
So there's a question of the order of operations. Yes, there is an order of operations, multiply and then plus. It's the same one you're basically used to from math class kind of thing. Look at some of the notes I had you read should talk about that, so make sure you read that part of the notes, okay? So I'm going to use a sort of fancier GUI text input box where it pops up a little window, says something, and then lets you type in a number or something like that, and it gives back to the program the value that was typed in there. And to do that, we have to tell Java we want to use more functionality of the language. So in Java, there's like this basic part of the language, the core Java, and you don't have to do anything to use it, so all this expression stuff and so on. But as soon as you start doing anything interesting in some ways, a lot of times you have to bring in other code into your program. And the way to do that is with an import statement. So I know where this extra code that I want is, and it's the kind of thing where, you can Google Java, how do I bring up a text box or something? And you hope to get some answer, and eventually you learn how this works. So I'm going to use this import statement that says to the Java interpreter, hey, go find this code. And a J option pane is something that brings up a panel in your window, on your program, and lets you interact with the user, okay? And so this is the kind of thing, it's just like you sort of have to learn what it does and what it's called, and it's okay to refer back to notes about it. It's hard to kind of keep all the details in your mind, but it's useful to know how to search for these kind of things, search for examples that work, and see how to use them. So instead of typing in a hard number here, I'm going to call my J option pane and ask it to show an input dialog. And in there, I give some helpful prompt that it's going to show up when this is run. So an input dialog is something that works for the user, and the text inside here is what's displayed to the user as the prompt for what they should be doing. So if I were to run the program now, oops, it's going to have an error actually. So J option pane show input dialog asks the user to type in some information, gives it back to the program, but it always gives it back as a string. All right, that's the only way it works. So I'm going to have to turn this into a string. And I'm going to call this the bill total string, just so I remember what it is. And let's actually print out what that bill total string is so we can see if we capture that information correctly. Now, notice this used to be bill total, and I used that number in my code down here. See how right now this bill total has a red underline on it? It's basically complaining about something, and if I hover over it, it says bill total cannot be resolved to a variable. In other words, this looks like something that's a variable. You're using it in an expression, but you haven't defined it anywhere. So before I had initialized bill total up here, I declared it, but it's gone. So Eclipse is helping me out by saying, hey, there's something wrong here. You messed up. So I need to make my bill total again and give it a value, and then that little angry red underline goes away, right? So the problem is now I'm sort of halfway between two different programs. I have my old program that uses double bill total, and now I'm trying to get that information from the user, but I haven't done enough yet to integrate it in with the rest of the program. I'm just trying to figure out kind of what's going on. So kind of think of these as two separate programs at this point. I have one that asks the user for a number and gives it back as a string, and I'm going to print it out. And then I have my old tip program down here that does its thing. So let me just run this, and then so I run it, and it pops up this more familiar looking sort of GUI kind of thing. Has this generic Java icon on it, but I can type in what I think is a number, and it prints it out down here. So we captured that value from the text box. Okay. Do you have a question? Yeah.
Just a quick question on this. So you've got the bill total equal to 100, but then we're also asking
I stored that in bill total string, and eventually I want to turn this into a number that's going to be set to bill total. All right. So the problem is right now, bill total string is a string of characters. It doesn't know that it's a number. It just thinks it's like David or cat or whatever a string is. It happens to look like a number, but it doesn't know that it's a number yet. And then down here, we actually need it as a number. So we need to do one more step. Here, I'm going to say, hey, if you're a double, do something called parse double. Parsing means go through the text and turn it into something. And I'm going to take a string, bill total string. Oops, that moved around there. There's my little bill total string. And what this does is say, take a string, interpret it as what I'm asking to interpret it as. In this case, I'm asking it to interpret it as a double, like an actual double value. So this turns the string into the equivalent number that it looks like. So if I have a string, in a computer, this is represented as a character 1, and a character 2, a character period, and a character 5. That's what a string is, a sequence of characters, right? I can't do math on this. This is just characters. So we need to turn this into an actual number. And the way to do that is you say, hey, I would like a double out of this string. And since I type in something that looks like a double, it succeeds, basically. If I typed in David, it would complain and do something else we'll talk about in the future, but it basically caused an error of some kind. Okay? So it's a two-step process. I'm asking the user for some information. These input dialogs always give it back as a string, just because that's a nice, safe way to grab information from the user. You can type whatever you want in there. And then it's up to me to turn that into the form that I want to use it as. In this case, a double. Okay? Now, this is no longer hard-coded with a literal of 100.0. When I run the program, it will keep asking and let me do different things. So if I run this, check them out. I'll go back to my familiar 100. And it worked. I can run it again. And try something a little smaller, a little more realistic maybe. And it gives me a tip here. And so on. Okay? So now the value comes from the user, but we have to massage that data to turn it into the kind of form we want.
So why do you need double parse?
It's basically, that's where that code lives. And we'll have to talk, again, there's some stuff we haven't had time to kind of talk about, but these doubles are sort of, they have their own collection of code, and this organizes it into a sort of a certain way of doing that. So typically, if we're doing some program that asks for multiple things from a user, and you want to turn them into different things, you have to every time do this two-stage process. Ask for it, and then massage it, convert it into the form that you're interested in. Okay, so just keep that in mind as sort of a general problem-solving strategy when we're using these input dialogues.
It would be helpful to do it kind of the way you did, where you sort of design it to be a specific value, for example, 120, and then go back in and...
Yeah, so the question is how to build up to this, right? And to be honest, it's sort of a pain to debug programs when you have to keep entering values. Like to run it, you have to type in your values, and if you're doing this a million times, you get very frustrated with it, right? So as a problem-solving approach, I think it's great to go the way I did it here. Like, do you have your math correct? Test it with some known values first. Check your math, make sure that's all working, and then try to add the input as a second stage. So you're always in good shape when you're programming to kind of build stuff up in small steps where you believe that what you have so far works, right? You don't want to write the whole thing, a whole 10,000 line program. You've been working for 3 months on it or something. You never run it once. You hit go. There's like no chance that is ever going to work, right? So one skill you'll pick up over time is how to figure out what's like the smallest path to getting something out on the screen or some kind of result that I can check. And that's an important skill to work on. Okay. So that's pretty good. We have a pretty fancy program. I could do the same kind of thing here for the tip the tip percentage if I wanted, but I'm going to leave that at 20. So this will be the good tipper application, and I'll just force them to do 20%, 25%. Now, let's see. Let's say I wanted to just for make this a little little easier. Actually, I'm going to go back to the hard code, the literal version of the build total. Okay. You can find this program in the code I uploaded onto the website, but I just want it like this. Okay, so we're back to our easier version. And let's say when I run a program, I'm always going to be hanging out with my friend, and we always want to make sure there's like some split going on, and we want to calculate 2 separate tips. That's sort of the common behavior I want out of this thing. So one could imagine taking that code and copying and pasting it, and doing it again. So one for me, one for my friend. Right off the bat, when I paste it in there, I get all these complaints, right? Here, build total has an angry red line under it. And if I hover on it, it says, duplicate local variable build total. So it's saying, hey, you've already declared build total to be a double. Don't do that again. You don't need to do it. And so some of you might be frustrated with that because you're like, I want to declare it again. What's the big deal, right? But what the program is trying to, what Java is trying to avoid is having you do something like this, where it starts off as a double, and then you're trying to change it halfway through the program to something else. And then when you use it, you don't know which version of those you intended, right? So Java, once you declare it, you have to leave it and not declare it again. Of course, that doesn't mean I can't say build total equals 50. I can put a different value in it, right? That's different from declaring it. So assigning a new value is very common in variables. It can hold 2 different things. For a while here it holds 100, and then later it holds 50. That's cool, I can do that. But if I wanted to, so I could reuse the variable. Another approach that is sort of a bad habit, but one people get into pretty quickly, is to make a second version of all these variables by giving it a different name, right? So up here I had build total, and then down here I have build total 2, tip percentage 2, and then I have to make sure to use these updated versions in my code, and I got to change the value here to something else. My friend did not order the same kind of expensive stuff I did, and here I got 2 different outputs from this. It ran it once for this version, and then it ran it once for this second set of code. All right, so I'm just basically doing what I did before. I'm confident it worked, and now I'm replicating it, and that's pretty cool. Questions about that before we go on? So I'm just making more variables and using them, right? Now, one problem here is that works for me and a friend, but let's say I take you all out to lunch. No, I'm not taking you out. You all have to pay for yourself. So you want to know your own tips, right? So what would I have to do then? I would have to put in 250 versions of this, which is a pain. And when I do that, I'm going to get very bored cutting and pasting that 250 times. And so it's pretty likely at some point I'm updating this to version 122, and then I forget to change this one here, and then when I run 122 here, notice this code is intermingled the variables 122 plus the second person's one, and it's wrong, right? So it's going to give the wrong answer here. And that's just because it's hard to keep track of all these different versions of these variables I made, and it's hard to keep updating this math here to make sure it's correct. So there's problems when you start replicating this code like this over and over again. Errors are easy to creep in, easy to make mistakes, and so on. So we're going to do something else where we're going to add another method that does the calculation for us, and we're going to use that method over and over again. So let me just sort of show, actually let me do another little example here. It's a little easier. I'm going to comment those out. We'll talk about comments more in a minute here. So there's no code in my main function now. It looks like there's code, but the stuff with the slashes in front of it won't run, okay? So basically, put those out of the way a little bit. So I want something that says, hello to me, I'm lonely, and this makes me happy. So if I run this, it says hello, yay, I'm happy, right? Now the problem is, on a bad day, maybe I want to have that happen twice. So again, I'm replicating code, and that's sort of a bad thing. So it says hello, hello. Let's see, I should make that a little bit bigger so we can see both. Okay. And I can keep doing that. Now, instead, I want to capture this action of saying hello and put it somewhere where I can reuse that in some known way. So I'm going to make what's called a static method. And for now, those are all going to start with public static. And then I give it a name of some kind, say hello. And then there's going to be what's called a list of parameters that we're not going to use right now. So for now, it's just parentheses. And inside here, I'm going to do this action that I want. So this is declaring this, this method. And it's basically a chunk of code that does some set of behavior, some set of statements. Maybe just kind of really get my morning going. We'll, make this a very friendly little program. So this part up here defines what this method does. It doesn't actually run it when it first sees it, right? It just says, hey, I know about this thing called say hello, and what it does is say, hello, you are awesome. To make it run, to make it execute, we have to actually do what's called a method call. So down here, I'm just going to say hello. It's complaining about something. What are you complaining about?
Say hello means return.
Oh, I know. Yes, thank you. We'll ignore this void for just a second here. So when I run this program, what happens is it says, okay, where is my main method? It searches through the program to find it. It goes to the first line of the main method. It says, oh, this is a method call. Go find that method and execute the statements inside there. So it goes to say hello. It jumps up here, does these two statements. When it's done with a method, when it goes out of this block, the curly brace area, it goes back to where it first called it and goes on to anything else that's there. There is nothing else there. I can do another thing here. System out print line. Go. I don't know. What's another friendly thing to say here? I've run out of nice things to say. I'm just not that nice, I guess. I don't know.
Believe in yourself.
Yeah, believe in yourself. Okay. So when I run this again, the order of execution is, so you say hello. It calls this method and does the statements inside there. Hello, you're awesome. It jumps back to where it called it, goes on to the next line, and says, believe in yourself. So if I run this, hello, you're awesome, believe in yourself. Man, I feel better already. Now the thing that's an advantage about a method is that I can use it over and over again. So I can call say hello again, right? And now it's really going to pump me full of stuff. Hello, you're awesome, believe in yourself. Hello, you're awesome, right? So it's a way of reusing code without having to rewrite the code. So if I did this for the tip calculator, I would do the calculation for the tip calculator, maybe in a method, to make sure I wasn't cutting and pasting wrong as I did this.
What's the purpose of static? Because you could write that same method without the word static in it.
So we'll get to, we haven't done enough about this yet to really describe it, but static means you can call it without making an object first. So we don't know what that means, but that's what it means. So we'll be doing some static function stuff for the first couple of weeks before we move on to more full-fledged object-oriented programming.
What would you write to, like, let's say if you didn't want it to return, on the same line, how could you change that?
Oh, you mean you want it to, when it outputs not, so I'm going to do something like this. So if you say print, it doesn't add a new line at the end. Although you are awesome. Right? Now the grammar's a little bit, or the punctuation's a little bad there, but that's fine. All right, so let's use this concept in our tip calculator. So I want a method that actually does the tip computation. And the tip computation is basically this line here. So I don't want to have 100 versions of that in my code when I'm calling it over and over again. I still need different versions of the numbers here, but I don't need different versions of the calculation. So I'm going to want something. So I'm hitting, on my machine, it's command / and it comments off or on the whole selected block you have. It's a nice thing to do. Let me get rid of this for now. Well, let me get rid of this for now. Okay. So somehow this piece of code is important to this program. It's like the core computation is happening. And I don't want to repeat it over and over again and make mistakes with it. So I'm going to put it in a method where I can be sure it's correct and then use it over and over again. So I'm going to make a public stack method called calculate tip. Calculate tip. Now the problem is, what do I need to know to calculate the tip? We know this already, right? But just remind yourself, what information do you need to know to calculate the tip?
Percentage and amount.
So we had the bill, and we had the percent, right? Now the problem is, if I were to put in here, let's copy that. I think I have it pasted in there. So if I have something like this, this method doesn't know about bill total or tip percentage because those are declared down here in this main method. And variables are only known in the method that they're declared in. Okay? So I can't use those up here. And I don't want to use them either because sometimes I want this to be bill total and sometimes I want it to be bill total 2 or bill total 120. I don't know which one of those I want to use. I want to use it for all of them. So we're going to make this generic and just work on whatever information we tell it to work on. Now, methods come from basically from the idea in math, functions. And most of you have probably seen something, if you've been up towards calculus. I define a function that takes an argument x and then adds 1 to it. That's what this function does, right? So how do I use this? I mean, we all look at this a lot of times and we sort of know what it does, but if you actually want to use this function, what's the math notation for doing this?
You would be, how do you use it in the code?
No, like in math. If I wanted to actually find it for a particular
value for x.
So I'd pass in, I would give some value for x here, right? I'd say, tell me what f of 5 is. And what happens is that 5 gets copied into the x. 5 gets copied into the x here. It evaluates this expression, 6, and it would say, this turns into a 6, that function call, right? We pass a value in. It works on that value under some abstract label, some generic label, and then does the math, and it gives you the answer back. So if that seems a little mysterious, go back and try to remember functions. I know you've done it, elementary school you do it basically, but it's been a long time possibly, so you want to remember how that works. The same kind of thing works here. So a method, we define some information coming in, and in this case, you just have to say what type it is. It's a double bill amount. And I'm going to just put it on a separate line here. It doesn't matter in Java whether you put new lines and where you put white spaces and stuff. And then I have an int tip percent, I'll call it. Okay, so I'm basically defining for this kind of function what kind of things come in and what those things are going to be called. Then I can use those in my code. So here I do know what this variable, these are basically just variables. They're called parameters. Right up here, they're called the parameters in the function of the method. And we use them like variables in that method. So I'm declaring this parameter like I declare a variable, and it acts like a variable in that chunk of code. Okay, so here I've declared this thing, and at this point I could actually print out the result of this. So I could print out tip amount if I wanted to. And now I'm going to change the code down here, not to do the calculation by itself, but I'm going to say calculate tip as a method call, kind of like I did for say hello. And when It's going to declare bill total, declare tip percentage, and then it's going to call calculate tip. Now it's complaining to me because when I call this method, I have to give the information that is requested here. Okay? So I have to pass in a value, like I passed in a number to a function. And so I'm going to pass in here bill total, and the value in here matches up with bill amount. So if there's 100 in here, bill amount gets initialized with that value of 100. All right? So the value gets passed up to this parameter here. And then I'm going to pass in tip percentage. Let me just get rid of this stuff here for now. Okay, and all that stuff. Actually, hold on. I'll leave that. Okay, so I'm still declaring variable, initializing it, declare variable, initializing it. I'm passing that value. It's stored in that variable up to this method here. And so if I were to print here what's stored in it would tell me the value that entered into this method, okay? So here I'm going to pass in 100, and it should print out the bill amount as 100. And then it does the work on that, and it prints out the answer. So let's try running this for a second first. Okay, so when it executes, it finds main, declares initializes this variable, declares initializes this variable. It sees this method call. It finds the value stored in bill total, gives that to be bill amount. So now there's a little variable called bill amount that holds that value. Same thing with tip percent. And it can print it out, do the work on it, and print it. Now, down here, I can do a similar thing with these other variables. Bill total 2 and tip percentage 2. And in this case, when it makes that method call, it's going to find the value stored in bill total 2, which is 50, pass that 50 to this parameter, and bill amount is now going to hold a 50. Last time we called it, it held 100. This time it's going to hold 50. And it's going to work on that 50. So we have two versions here. Bill amount is 100, tip is 20, bill amount is 50, tip is 10. Okay, so this is a little confusing. We're no longer just going through our statements in main, top to bottom. We're kind of jumping around the code, right? So the way you execute things is not always top to bottom on the page. Different statements have different behaviors. You can loop around, jump around, all sorts of things. Question?
So the name that you set up for parameters can be saved with the objects you declared.
So are you asking here whether bill total could be used up here as bill total?
Yeah.
You can. It's very common to do that, but it's a little confusing because notice next time I call it with bill total 2. So you don't want to get confused that this bill total is exactly the same as this parameter. The value is set to it, but this is a new variable basically. Okay? It's an important distinction we'll see more of in that.
Is it still the same case if it's in the main method also, along with the...
So we do not know, if I try to use bill amount here, it doesn't know anything about it because that exists only inside this code block for the method. Now let me do one more little thing here before we head out of here. This is actually kind of a bad method. The reason is methods should do one specific thing. And what does this method actually do? Tell me what it does in some English phrase. Yeah.
It calculates it and then prints it.
It calculates it and provides the output, right? And so it's intertwining two activities in what should be conceptually a nice, easy to understand one thing. So I would actually like to pull out this print line here and put it back here somehow. Now the problem is, notice, tip amount is declared in this method. The main method doesn't know anything about it. So we need to get the information out of this method and get it back to here. So the way you do that is with a return statement. So I'm going to say here return tip amount. Tip amount. Tip amount. This says, take this value and make any call to this method evaluate to whatever is returned here. And I have to say, instead of void, which means don't return anything, I have to say I'm returning now a double. So this line is pretty confusing. Again, we're going to sort of ignore this public static. This third thing says what kind of value is returned out of the method. This is the name of the method. And now, when I call this method, it evaluates to that number, tip amount, and I can assign that value to a new variable, tip to pay, and I can print that out. Okay, so the return lets the information come out of the function, the method. The parameters let information come into the method. So those are very important concepts. You want to control the flow of information in well-defined ways in this thing. If I run it, it should still run, hopefully it works. Okay. For your assignment, you're going to make a small program that has two methods. And so you'll want to look at the example code that I already posted, see how this works, and do something similar for your assignment. We didn't talk about comments today. You have to do that for the assignment. We'll talk about it next time. You can also do that. I have some links. All right.